Our today's lecture will be a preparation for our lab tomorrow, where we are gonna use the FPGA kit that you have. In our last homework, we had the assignment of 4-bit shift register and 16-bit register. This is parallel in, serial out. And the 8-bit up counter. And finally, the 16-bit up down counter. This is my solution. For the 4-bit shift register, I used the concatenate. This is the AND sign. In this concatenate, I am adding, concatenating this input DIN to my D flip-flop. I have how many D flip-flops? I have D flip-flop. It is 3 down to 0. D flip-flop, it is 3 down to 0. But here what I'm doing is I am concatenating 2 down to 0, not 3 down to 0, because this new D input, my new serial data in, it will push 0 to 1, 1 to 2, 2 will go to 3. At the end, I will be printing the D flip-flop 3 out. For the 16-bit, here again I use the concatenate, but here I am shifting to the right. I am putting this 0 to shift bit 15. It will go lower, 14 lower, and 1 finally will go to 0. With this command, I used the load. If load is high, I am shift registering DIN. DIN will go to SR. This is all the 16-bit will go to SR. Else, shift high. Here I start shifting. After I finish with this process, the shift register, whatever the data is, I will push it out. This will be my output. For the 8-bit up counter, I have a signal 7 down to 0. When I have the clock rising edge and I don't have reset, if reset is 1, counter will be 0. If reset is 0, I can start the counter. Jose? Hello, Jose?
Yes.
This system, the process you have, we have a reset. Is it synchronous or asynchronous?
Asynchronous.
Do you know what is the difference between synchronous and asynchronous?
Wait, there is a clock, so it will be synchronous.
Yes, there is a clock, So it will be synchronous. How could I make it asynchronous? Chad? Hello, Chad?
Yes, Professor.
How could I make it asynchronous?
By removing the if statement that allows it to be synchronous with the clock.
Not really.
No?
No.
By just putting it by itself then? Without having it attached to the clock?
We have to do two things, not just one thing.
I'm not sure then.
Okay. Hello, Paige?
Hello.
Any idea? To make this asynchronous reset? Whenever there is a reset, I don't wait for a clock. Just reset immediately.
Can't you take rid of the clock variable and what Chad said?
Would you all please go back to lecture 1 and look it up? You have 5 minutes.
It wasn't setting the clock equal to the reset.
Please don't answer. Give them a chance, then we'll be back. I'm waiting here 5 minutes. So everybody will look it up.
why did he change that clock?
Which clock? Hello, Paige? Vitaly?
Hello, Professor. How are you?
Did you figure out how we can make it asynchronous?
So, from what I understand, in your begin syntax and everything like that, you have the clock is first, and so that's what makes it synchronous. Is that everything depends on it. But to create an asynchronous counter here, you want it to be independent. So, would you create a clear that is prioritized first?
How could I create it?
You would have to create another input with a clear.
Where should I put it?
Well, first put it in your ports. Create a clear port.
Okay,
input.
okay. I'll put a clear port. Then what?
I see. Okay, so after you say begin.
By the way, reset is the same as clear.
Okay, very good. So you can say clock, comma, clear, then begin, and then say if.
Yes. Clock, comma, clear. So it should be one of the triggers for the process.
Exactly. So as long as it's triggered first, saying, for example, if clear is 1, then D out goes to 0.
Excellent. Thank you.
No worries. Thank you.
This is our 16-bit up-down counter. As you can see here, I have the reset. It is synchronous because it depends on the clock. It comes after the rising edge of the clock. I check if reset is high. In this case, the counter will be 0. Then I check to see, do I want to go up, increment the counter, or down to decrement the counter? If it is up, so it will be counter plus 1. If I don't have up high, then else I will decrement the counter. Now, this is our first time to start speaking about the FPGA kit that you have. In our week 1, I asked you to read about it and get to know it. Now we're going to go through it together, starting by the name. What does it mean? We have here 10M. This is the Max 10 family. This is the family signature. Then I have 16. 16, this means the memory you have, the memory card. 16 would mean 16K. DA, this is the features that you have. Here I speak about dual supply analog feature. So I have dual supply analog feature. Package, it is ultra fine line BGA. This is the package type. 484, this one, the package code. The package code 484, here it tells me this is FPGA and it is 484 pins, and the dimension of this FPGA, it is 23 by 23. I, this is the operating temperature. The one we have, it can work, if it is I, it will be from -40 to 100 degrees centigrade. 7, the speed of the processor. 7 that we select, it means that is not the fastest, but still moderate, and it can do great job for us. G, this is not a sample, no, it is G, means option for shipment method. What do we have in here? This is my processor. This is the one we select when we are doing the programming. We have here accelerometer, so we can measure speed. Keep it in mind, you may have a project, or you may think about a project to use it. 4-bit resistor VGA, I can connect here VGA. I have here 40 general purpose input output. Each pin in here can work as input output port. Can work input, can work output. Arduino connector, if I want to connect it to Arduino, and this is 5-volt supply, goes in here. Why do I need it? I can download my program and I connect it to a 5-volt power supply, and it will work independent from the computer. So it can control a whole production line if you just give it the power, the 5-volt power supply. This is my static RAM. And this is my 5-volt and ground 2-pin header. I have 7-segment display. 6 of it, 1, 2, 3, 4, 5, 6, 7-segment display. I have here 10 switches. We are going to use them. And I have 10 light emitting diodes and 2 push buttons. 2 push buttons that we can use. To use any of those, we'll see how we can specify which one I will be using and what will be the function. Will it be input or output? Of course, the LED will be output and the switch should be input. But for the general purpose I/O, those can be input or output. I have here D3 and D4, D1, D2. Those are 4 LEDs. Those gives you an indication about, for example, D3, when input power is active. D4, power is good from the supply. D2, FPGA is successfully configured. Very good. D1 eliminates on onboard USB cluster is working if I'm connected to USB, so D1 will be on. Do you have all your kits? Do you all have the kits? Hello?
Yes, I have mine on me right now.
What about the rest?
Yes, I have my own too.
Okay, would you please
Mine.
check your kits? Get your kits out
I have mine.
and look at it. We are not going to use it, but we need to be looking at what we'll be using tomorrow. We have here clock signals. Everything is working according to clock. I have 250 megahertz clock signal connected to the FPGA and use it as a clock source for user. So I have those 50 megahertz and they are connected to the FPGA, and those are fast clocks compared to the 10 megahertz. Those are connected to the outside world output for driving analog to digital converter. When you have analog to digital converter, you may not have very fast analog to digital converter. So 10 megahertz will be suitable for those. Here, if you want to use any of the three clocks, we can see here the pin number that you can use. Each one will have its own number. We have here, as I said, two push buttons. Two push buttons this is my 5 volt going through a resistor, and I have here key 0 connected to ground. In my Altera chip, the address of this one is B8, and this is A7, the other one, key 1. Samuel? Hello, Samuel? Hello?
Hey, you got two here, man.
Oh,
Which
I didn't
one?
get any one of them.
Which one do you want?
I want you.
The mouthy one or the other one?
Would you please tell me at this P0 position?
Open?
Yes.
Okay.
B8 will be high or low?
Low? Oh, wait a minute. Looks like it's going to be high. If it's coming from...
Why high?
Because the source should be the VCC, I'm assuming.
Yes, that's correct. That is VCC up here, yeah.
Yep. So if you wanted to short it out, you would push key 0 down, I guess.
So when this is open, the voltage will go to my Altera.
Mm-hmm.
So it will be high. When you close the switch, now we are connected to ground, so it will be 0.
Hell yeah.
The same thing for A7. But this push button, it has an internal spring. Internal spring. Look at, imagine the door, or imagine your car. If the car is running and all of a sudden you came over a bump, you will go up, down, and you will oscillate, then stabilize because of this spring, the shock absorber. The same thing will happen with this spring in your push button. It will oscillate, debouncing. It will oscillate before debouncing. So the push button is pressed here, and I have some oscillation. When all the oscillation go off, I will go to 0. So as long as there is oscillation, I didn't reach my 0 yet, and I reached it here. The same thing will happen when you release the push button. I will have some oscillation and I will reach the high. We are going to be thinking about software to eliminate this bouncing. It is called debouncing. This will be one of our tasks that we'll do. Here, if I want to use key 0, I should tell the FPGA I will use pin underscore B8. This will be an input pin for me. Key 1, pin underscore A7. I have here slide switches. This can be 0 or 1. 0 or 1. I have 10 of those. Switch 0 to switch 9. And each one has the pin number stated in here. We said we have those are the switches that we spoke about. Those are the 2 push buttons. And here we are going to speak about the 10 LED. The 10 LED light emitting diodes R0 to R9, and each one will have its own address. I need to specify which one will be used, and of course it is an output, and it can receive 1 or 0, so it will be on or off. This is a picture of my here general purpose input output. I have here, out of this general purpose input output, some of them can work with 5 volt, others are working with 3.3 volt. And I have here ground. Oh, sorry. This is the 5 volt input, the ground, 3.3 volt output and ground. So I can use connect to the outside world, 5 volt available for me to use, or 3.3 volt available for me to use, and the 2 grounds. And those are my, on each side, I have 40 general purpose input output. And those are the pin assignment for all of those. Cameron? Hello,
Yes,
Cameron?
sir.
How can we get hooked to those general purpose input output?
Do you mean like how do we hook it to an exterior thing, or how do we hook it to
Yes,
that?
we have exterior outside world. I want to connect it to the outside world.
Oh, you just got to connect the pin to whatever you're connected to, and then you got to find the pin on the FPGA.
Yes, I found this ugly pin. How could I get connected to it?
You got to look on the data sheet and see what GPIO.
I know this pin. How could I wire it? I wire it.
You just got to plug it in to whatever you're trying to get the signal from, or to.
Yes, plug in. I need the connector. Do we have connectors for it?
I don't think it comes with the board, but we have like the little jumper wires we could stick on there.
Do we have a jumper wire that can be hooked, female to be hooked to this male connector?
I don't think I have anything like that. They have the other pins though, the other ones there on the Arduino header ones that aren't with this one. That might work a little better.
Anyway, we need to think about it. If you are missing anything, you will think about how we get connected. I'm sure there is
May I
a
interrupt?
connector that plugs in to this directly.
I have a bunch of them. You can't have them permanently, but if you are here and need to borrow some, just come by and I'll find some for you.
Okay, very good.
Or I can rent them for the rest of the term.
How
Thank
much?
you.
How much?
Yeah,
Let me see. They're undergraduates.
yeah.
$1 a wire for the rest of the term.
Very cheap.
Yeah, that's only 40 pins. So that's only.
But we
40
have no money, period.
Listen, I've seen your car out there, so I know you have some money.
But no gas in
I'll
the
bring
car,
you
don't
donuts.
worry.
Yeah, donuts would be fine.
Okay,
No, seriously, I have a bunch of those. If you want to order some, I'll loan you some of mine, and when your order comes in, you can get them.
I believe there must be in the lab somewhere.
I couldn't find any, but I'm sure there are some somewhere.
And I believe there should be.
I know we don't have
One-
access to any of the hardware as students. It would have to be through James.
Okay.
That's Mr. Dr. Ballard, sir, to you.
Mr. Dr. Ballard, sir, is the only one that can do it.
Yeah,
Okay.
maybe a couple of us can go in there after class and look in the storage room there and find
No,
any.
they cannot
And
open
I'll
the
ask
storage room. They cannot open the storage room. Nobody will let them into the storage room.
No, I have a key. I just think that a couple of us can go in with me. There's so much stuff to go through that we can look together.
Okay. And if you can find a connector for pin by pin, because I know there is a connector that connects the whole pins all together. And when I get them out, I can connect to the printed circuit board, for example. But anyway, we are gonna need it especially for your project, okay? Now I have a little issue to discuss with you. Next week, we are going to have the daylight saving. With your daylight saving, I live in Phoenix, where we have no daylight saving. Sun is all over day and night, so we don't save any daylight. So it is not observed. So when you change the clock, I will have a conflict with other classes. Are you free 1 hour late?
That's easy to fix. We are more important than your other class.
Okay. Are you free starting, for example, 12?
I am.
I am not.
Hmm?
I'm free
So-
to start an hour earlier or an hour later.
Later.
Later, yes.
Okay. Would you please send me by email your class schedule, and I'll try to find some way out of this.
As long as you tell us exactly what to do and how to build it, we'll be fine.
Build what? Your class schedule?
Just our next objectives. And
No, he was meaning
For
if you
labs.
did your lectures so that we could listen to them later if they can't do them at noon.
No, let's start first by getting some common slot that we can meet. If not, we're gonna figure out another way. But would you please send me by email your class schedule? And when we meet tomorrow, I'll tell you what is the best fit. You have my email?
Yep,
Hello?
sounds good.
Okay. Please send me your class schedule and I'll try to find best way we can meet. Okay? I think I'll stop at this point and see you tomorrow in the lab. Please don't forget to bring your kit with you. We are going to use it. Thank you.
Will the lab time be changed too?
Everything will be changing, but I don't have a conflict with the lab. The lab
Oh.
will start early.
Well,
Okay.
we need
Tomorrow at
oscilloscope.
7.
Pardon me?
Tomorrow at 7.
Tomorrow we have lab, yes.
At 7, yes.
Yes.
Will we need anything extra like a function generator or like an oscilloscope or something?
No.
Cool.
Professor, I have my own jumper pins and a few other electronic components. So as long as I have my computer and FPGA board, would I be able to do the lab from home?
Yeah,
Okay, perfect. Thank you.
thank you.
Thank you, Professor.
Are a bunch of you in the lab now? If you are, I can bring you pins right now.
Okay, all. Thank you very much. See you tomorrow. Bye-bye.
Professor,
Bye-bye.
Bye,
Professor.
sir.
have a good day.
You too. Bye-bye.